So while this is getting set up, I'll start off by saying I'm honored to be invited to speak here today. And as stated, I'm the chief architect for the Intel IoT platform. I'm not going to talk to you today about the Intel IoT platform, though. What I would like to talk to you today is about trends that I'm seeing in the Internet of Things, opportunities that seem to be presenting themselves globally. You just heard a fantastically interesting discussion with the previous speaker. And I'd like to talk about transformation, specifically in industry with the Internet of Things, and hopefully leave you with some thoughts about observations that I've had from my brief visit here in Australia and opportunities that I think that each of you here can consider when deciding what does IoT mean for your country and where do you want to take it. So I'm not going to give you the definition of IoT. I'm assuming all of you understand what it is. I'm not going to explain how you have sensors and actuators and data aggregation devices and cloud computing. There are a few things that are important. We talk about numbers. We talk about 50 billion devices. We talk about zettabytes of data. Not many people know what a zettabyte is. It's not something that I think of. I know billions. My mind has finally adjusted to $1 million isn't that big of a deal anymore in the grand scheme of things from businesses. Billions are now there. So a zettabyte, 44 zettabytes, it's a billion with 15 zeros behind it. So we're talking about a lot of data. The volume of data is so extraordinary. In 2014, humankind produced more data than what we produced in human history starting from December 31st of 2013 and before. 1 year. 1 year we produced more data than anything else in the history of humankind. And most of that was cat videos, apparently. I don't know why that is. But in all seriousness, we are in an absolute revolution of accessibility of information, as you all know. It's why you're here today. But there's a couple of reasons why that revolution is occurring. And it's important to consider the variables that are enabling it, because that's your proof point in the transformative value of the revolution that we're in. Now, Internet of Things is becoming this overnight sensation that's 20 years in the making, right? People are talking about it more and more, but the reality is this has been going on for a long time. And one of the things I'm going to share with you is my background from working in the semiconductor manufacturing industry at Motorola in a previous life and at Intel for the last 15 years. And going back into the late 90s, Intel's been working on innovations in Internet of Things to keep our business model viable. IoT has enabled for the last 15 years the extension of Moore's Law, before the term IoT was being used readily. And it's enabled because the cost of computing, the cost of storage, the cost of communications is dropping at such a significant pace. And now we're also seeing reductions in the cost of sensing as well. The magnitude of this is staggering in my mind. A fact. A single transistor on a processor, a single transistor that can switch 3 billion times in a second. 3 billion times in 1 second. If any of you wanted to switch on and off a light 3 billion times, you'd need about 100 years with no bathroom, food, and sleep breaks. So 3 billion times in 1 second on the latest, most advanced technology nodes that Intel has at its disposal costs less than it cost a rural Chinese farmer to grow a single grain of rice. So a transistor that can switch 3 billion times a second is cheaper than a grain of rice. If some of you read the newspaper this morning, the letter E in a newspaper costs more to make than a transistor that can switch 3 billion times a second. The commoditization of compute, comms, and storage enables us to put compute, comms, and storage in places we never would have dreamed of 10 years ago. And that decay in the price of compute, comms, and storage is not looking like it's nearing a plateau. It's going to continue to drop in the years to come. So it's the commoditization of the transistors enabling the IoT revolution, because now you can deploy connected intelligence in places you never could before. Now, what does the future look like for this is something that's important for us to consider. Given that this is the transition that we have to look at what impact is this going to have on human existence. Now, there's a transformative effect that the automobile industry had as a result of some of the innovations that Henry Ford had very early in automobile history. I love the previous reference from the previous speaker. It was a great lead into what I'm talking about here. That was catastrophic to the horse and carriage business. It was. When you have major revolutions in technologies, there are winners and losers. That's clear. However, I think that the perspective that you use for Internet of Things deployments can be very positive if you choose to do so. And this is the thoughts I want to leave you with and as we have our discussion on the transformative benefits of IoT. The future of IoT, era of ubiquitous intelligence, delivering exciting new user experiences, unleashing human potential. These are fantastic marketing words. What does this mean to us? I want to talk about what it has meant to Intel and me in my career. Some of you may or may not know that Intel, of course, is in semiconductor manufacturing. It's a very high-tech field. The manufacturing complexity is very intense. The innovations required to extend Moore's law are obviously pretty extensive. Intel has a pretty large R&D budget in the order of $11 billion plus per year in order to sustain that investment in innovation. But I remember early on in my career as an engineer sitting in Arizona in the United States, working in a factory, and hearing conversations about what is the future of manufacturing in the United States. And these questions were being discussed at a business level for Intel. Should we maintain manufacturing capability in this expensive geography? There are economic advantages if you look at currency conversion rates to move to other geographies. There are wage rate differences in other geographies. Clearly, the US isn't one of the cheapest places on earth for wage rates. So there were a lot of questions and discussions about what does this mean for the future of manufacturing at Intel. Now, I'm delighted to say that there's 4 factories at that site today, where there was 1 at the time. And I'm delighted to say that I had the chance to spend about 12 years of my career working on Internet of Things practical applications in manufacturing to try to reduce the cost of manufacturing, to try to improve labor efficiency, to try to improve the quality of manufacturing, improve the velocity of the manufacturing process to make it easier for customers to get parts when they need them, but try to use the skills and the intellectual capability and the experience of the workforce in new ways to think about how we can automate tasks, make mundane automated, and get our humans that are responsible for the success of these buildings, these manufacturing facilities, get them working on improving the systems, not actually pushing the buttons to make the systems go. Now, you could look and say, okay, so as a result of this, were there massive layoffs once you started automating things? And these are questions that people have about IoT. Just like building a car, you can choose to manufacture a car for fuel efficiency. You can choose to manufacture a car and optimize for performance, to optimize for being able to haul heavy cargo, to optimize for safety. When you're choosing to deploy IoT, you can choose what you want to optimize for. And in the case of what we tried to do in that example, which I think it was transformative for the company, we tried to optimize based on competitiveness. We wanted to have the competitiveness so that we could grow. We could grow the business. And by doing so, we recognized that we had employees whose world was going to change. They were going to go from go, some of the more manual tasks associated with manufacturing, to watching these automated systems perform autonomously and be able to manage those systems, looking at automated process control algorithms, statistical process control analysis, teach these individuals how to become a different type of skilled worker in the marketplace. And this is something for Australia to think about, I think. Some examples of what was helpful in that particular instance was recognizing the changing needs of the worker meant that workers needed to adapt. And science, technology, engineering, mathematics, these STEM areas are critical for the success of IoT deployments. It was absolutely critical for semiconductor manufacturing. So public and private institutions partnering with the industry to try to give workers new skills. One specific example that was orchestrated with a local university enabled us to take employees that were still paid by the company, and 1 day a week was spent working on an engineering degree. And it was an accelerated program. 2 years later, they're still in the workforce continuously, so they took no wage impact over that time frame. Intel's retained an employee that has a decade plus of experience with the company, understands the systems, understands how they work, gave them the knowledge and the skills they needed to make it improve even more. And part of the curriculum, just to try to make sure that we were getting value for the money, was to make sure that each of those students were working on projects to actually deploy improvements in the factory while they were getting their education, like a 2.5x return on the investment. So you can make it positive. You can choose to invest in the employees, and when they come back from that education process, now they have an engineering degree, and they go from being a lower wage hourly worker to a salaried engineer employee. So they actually see career benefits from that. So what's been nice to watch over the years is watch the scale of manufacturing grow in the US while other industries chose to outsource, because the power of IoT was harnessed to achieve competitiveness, global competitiveness. And partnerships with local, other private companies, universities, and that collaboration with local governments as well helped enable that transformation that kept manufacturing in the US competitive. And today, Intel has more manufacturing facilities in the US than it has anywhere else worldwide, which is nice for a US-based company. So other things you can think about from those examples: wearables, wearable technology. Is this something that's going to take off? Of course it's taking off. Lots of people have Fitbits. They're using it to track their health. This is something that Intel's been deploying going back about 6 years, having technicians and factory workers with small wearable devices that, rather than having to log into workstations and type in their username and password, and they walk by a machine, swipe, knows exactly who they are, what their skills are, what they're certified to perform on that equipment, they can get to work right away. Improves productivity. You can choose to use these technologies to try to improve competitiveness. And in the regional economy, I think Australia has some fantastic opportunities looking at some existing industries to improve competitiveness and build on strengths that Australia already has, and extend that even globally in some industries. So the examples that I gave for future of IoT, that's more industrial based. If I look at other industries like transportation, I think you just saw a fantastic presentation. There's no way I can give you examples better than the previous speaker around Uber, and ways you can revolutionize the human experience around transportation. If I look at agriculture, Australia actually has some leading technologies in agriculture, revolutionizing the winemaking industry. This is going on now. If you look at the future of agriculture, you're going to see opportunities for differentiation in the marketplace as a result of some of these industries. So there's a couple of principles of business that I learned a long time ago, and it's important to think about this in any industry. There's 3 primary ways to make money in a business. You're first, you're better, or you're cheaper. What Australia has, to me, is when you think about agriculture, is already a fantastic reputation of better. If you compare the perception of goods coming out of Australia for produce and for wine compared to goods coming out of other Asian geographies, I think that there's already a value in those marketplaces perceived of what Australia can do. Harnessing IoT to try to revolutionize particular industries to make it easier to cost-effectively produce better products than what can be grown in other regions is a huge opportunity to expand industries, expand the ability to actually make significant margins on existing industries. And we're starting to see continued transformative value coming into agriculture. Brazil, I think, is a fantastic example. Brazil used to be the leading coffee maker in the world, and saw a lot of other coffee growers show up in other regions. And that was very impactful to the Brazilian coffee bean plantation economy. Brazil started taking a different approach using precision agriculture to try to make better quality beans. And having been there just a couple of months ago, it is fantastic coffee. I'm not much of a coffee drinker, but I can't stop myself when I go there. But they're trying to build that better approach. And they're using IoT-based solutions to help with that. They're looking at innovations in precision agriculture to understand soil composition, to understand watering frequency, to understand when should pesticides be deployed. And they even have many different agricultural industries that are doing precision agriculture through autonomous machines. So tractors that leave the barn on their own. They're manufactured without even seats. There's not even a place for a person to sit if they wanted to. Completely autonomous vehicles that go in, plow the fields, and then come back at night when they're done. So these sort of revolutions in technology can enable and are enabling a boom in a business like coffee growing in an economy that saw a dip in that business. There were lots of people not able to sell coffee beans before until they made a decision collectively as a country, let's concentrate on having the best quality beans and focus on that rather than the cheapest output possible. They changed the equation. They decided to make money with the better approach. Now, I will talk about the fundamental tenets of Internet of Things solutions, and I've yet to find a situation where this isn't appropriate. When you think about Internet of Things deployments, when you think about where you're going to implement an innovation to achieve first, better, or cheaper in some business or industry, there's a few key ingredients that so far have proven to be universal in my experience talking with many companies, hundreds of companies across pretty much all the continents, but Antarctica so far. You have to have a few things, a few problems resolved in order for that Internet of Things solution to be successful. And I'd like to be able to take credit for these, but these tenets are like principles. They're guiding beliefs that you use to shape decisions that you make. These are supported by a lot of major industry players. Intel went public with these, with GE, IBM, Cisco, AT&T on stage back at the Intel Developer Forum, September of 2014. Many companies are looking and seeing that, yeah, this is actually something that's very important to consider. It's not that this is a formula, but these are factors that you have to pay attention to, and they're read from the bottom up. And what's critical is that you have security as a foundational element in your IoT solution. From what I've seen so far, we talk a lot about security at a very high level. Most companies are sure to include it as a bullet on their marketing propaganda. But if you look a little bit deeper, you realize, okay, there could be some gaps here. And as we start deploying security, or as we start deploying IoT solutions for critical infrastructure, this can become very problematic. You need to be able to protect these solutions. Now, there's varying degrees of security that are required depending on the application, but if you don't address this up front, you'll have a problem. Now, if you think about this, we've solved this in some industries already. Mobile computing, right? Mobile phones, smartphones, everybody has one. If someone dials me, right, it only rings my phone, and maybe Obama's or National Security Agency or something probably gets the call too. But we have that figured out through the SIM card, right? That's a combination of hardware and software that helps you provision those devices so that you understand whose device is it, what's their identity, and how do you know it's in your system? Now, what worries me about IoT solutions is where you have tens of thousands, hundreds of thousands, tens of millions of sensors all sending data. How do you know whose sensor is yours? Whose sensor is someone else's? How do you know that someone else isn't trying to put their sensor in your system? How do you make sure that you have that captured? So having hardware and software level security is absolutely essential for the health of IoT solutions, and critical infrastructure obviously needs to be the highest tier of security. Connectivity, device discovery, provisioning, these are all things that we have to do when we get a new smartphone, right? You have to establish that. This has to be established as well, especially for complex self-healing autonomous mesh networks, right? As we start to move the technology farther down that spectrum, these are issues we're going to have to be able to resolve. And consumers and purchasers, people who are getting and extracting value from IoT solutions, they're going to want to have this be simplified. They're not going to want to send somebody out to the field to push two buttons at the same time to try to sync devices and make sure that they're actually working. Data normalization, this is key as well. Data normalization, right? Last look at the industrial segment, I counted 115 different languages that sensors speak. 115 different languages. So if you have a conversation with somebody and there's 115 different languages being spoken, it can be hard for people to interact. So this is a challenge that we have to overcome. And there are standards bodies, there are consortiums that are forming. Of course, Intel's involved in some of those. I'm not here for a sales pitch on that. But the idea is we need to be working on finding better ways of establishing healthy metadata formats, reducing the number of disparate protocols and trying to consolidate the industry. But even if tomorrow we woke up and someone said, we have it all figured out, you're not going to see aircraft engine manufacturers go abandon their protocol to adopt a washing machine protocol overnight, right? There's hundreds of millions of dollars invested in these industries. It's going to take time to get these things to be fixed. We have to solve some of those problems so that these things can be normalized. Many of you don't realize that you already have protocol normalization devices in your pockets, right? Many of you have modems that can run on 3G, 4G, Wi-Fi, Bluetooth, and you don't have to download a new app every time you switch from one to the other, because your smartphone manufacturers normalize that for you, so you can have multiple communication technologies, multiple protocols speaking at the same time, but it's seamless to you, the end user. This is something that we're going to have to continue to address. Actionable analytics. Ultimately, the value in IoT solutions is the data. It's being able to get access to the data and the decisions that can be made from it. There was a very astute gentleman sitting behind me, I'm not sure which one it was, pointing out the direction of autonomy, right? Eventually, all industries will drive towards some level of autonomy, and the humans won't be making decisions based on the data. The humans are going to be monitoring the decision engines. They're going to be monitoring how these machines make decisions and change the algorithms that these machines use. That's a skill change that has to happen in order to enable that. Monetize hardware, software, and data management. There's value in all of those. And if your IoT solution locks down innovation in one of those areas, it's going to have problems eventually. If you're embracing innovation in each of those areas, you're letting people extract value from the data, from the hardware, from the software, then that opens you up to multiple industries, and it enables you to collaborate in ways you wouldn't have otherwise. So as I'm wrapping up here, I'll leave you with a few thoughts. My simple observations for, actually this applies to any geography, but especially Australia. There's 3 things that I think can be done to try to help let IoT become a major economic driving force for this country. The first is understanding and focusing your investment dollars. So research and development, government funding, private equity investments, venture capital. If you try to take an approach where you're trying to accommodate everything, you can spread yourself so thin that you're unable to really win in a couple of key areas. Obviously, no country has infinite resources, so picking your winners. Picking winners based on what you know Australia can do really well and is already potentially having leadership areas in. Precision agriculture is one area I think that Australia could obviously do fantastic at. But picking a few winners. And when it comes to dollar investments, right, and investments in research and development, I actually don't get excited about how many dollars are involved. I care much more about how those dollars are being spent and to what end. So I don't think it's about spending more money. I think it's about choosing how you want to spend the money and what problems you want to overcome. And if the end goal is global competitiveness, is what you're trying to achieve with those dollars through innovations and technology, I think that's a very positive way to be focusing those resources. So picking a few winners and concentrating your R&D dollars as efficiently as possible. Second area, which I think is important, is understanding in those key focus areas, what are the government and private partnerships and alignments that need to be implemented to enable competitiveness in that particular industry. I think it's foolish to think that one industry is going to be bandwidth limited and the other industry is going to have some other limitation. You're going to have to look at each one and understand in that industry what are the key limitations. It could be that the cost of importing and exporting goods because of freight logistics is cost prohibitive. And that's an area where the government can try to work on infrastructural improvements with private companies as well to try to enable competitiveness in the global and local regional environments. The third category is science technology, engineering, mathematics. To me, this equation is very simple. It starts at age 5 and goes 50 plus. It can't be a process where you just try to make sure that individuals who are in their junior year of college choose to stay in engineering programs. That's something that you need to certainly work on. But it has to be an entire culture of innovation and making sure the entire workforce and the future workforce is embracing the need for technological innovations in these 4 key areas. Those are critical for making sure that you have a competitive workforce for the future of IoT as these innovations continue.
Brian, what keeps you up at night?
Yeah, I don't have a mic. I think one of the biggest areas of concern for me is governments trying to accelerate themselves in an IoT solution space at the expense of the benefit of the global economy. I think that we all benefit from the fact that, like our laptops, you can sit at a cafe in Mumbai or in Sydney or in London and connect via Wi-Fi because the world decided, hey, let's have one standard for mobile device communications. I'm seeing several countries look at coming up with their own IoT standards. And what that can mean is we're going to end up with these like little converter boxes that we have to have when the world wasn't standardized on electrical grid and connection points, right? So it would be really nice in this day and age that we can have some consolidation. And so the industries are trying to move very fast to try to capture some of that risk, but I don't think we'll be able to convince all regional governments to not end up interfering. Good question. Other questions? Okay.
No? Okay. Oh, no, one more? Yep.
Thanks, Brian, and thanks for coming all the way out here to be with us today.
Sure.
I'm just wondering, what do you think are the implications for Australia if we don't start getting involved in the Internet of Things in a sort of more proactive sort of way?
Well, the implications for anybody who tries to not follow the revolutionary trends that industries are going on is the same implications that there were for the horse and carriage industry when there was an automobile revolution, right? You can't deny that this is happening. The question is, do you want to use it to your advantage? And as a developed country, you have the opportunity to do that and maintain competitiveness in a regional and global ecosystem. So I think that the consequences of not moving quickly are pretty significant in terms of lacking competitiveness in a global environment.
Okay. Ladies and gentlemen, please
thank you for giving me the opportunity.
Thanks, Brian.